Hey guys, this is Academia on Demand and I'm Josh Myers and I'm bringing you the fourth video of our chemistry series of this channel, and we are going to be talking today about chemical bonding. So, in our last video we learned about how to draw atomic structure, how to know the number of protons, neutrons, and electrons, how to draw atomic atom structure. So how does this apply to chemical bonding? Well, also in last video we talked about how valence electrons, how the number of valence electrons is a common characteristic of a vertical group, and group being the vertical row in the periodic table. Characteristic to group. Very squeaky pen there. And this is very important to what we are going to be talking about with chemical bonding, because in our last video we also discussed how these elements that have certain valence electron numbers defined by the group that they are in, we talked about chemical feelings, that they have an affinity, they have an affinity to gain affinity. Did I just move you? No, I didn't. You are perfectly fine. They have affinity for, to gain a full outer energy level. Valence energy level. This idea of valence or outermost energy level. So the most outward energy level from the nucleus. That's energy level. So now we're going to explore this idea a bit and how it can lead into chemical bonding. And it was actually hinted in the last video when we talked about lithium and fluorine. So let's erase for a second. Let's leave that bottom part actually, just so we can remind ourselves as we do this cool chemistry stuff we will be doing. Alright, almost done erasing. We are almost there. Okay, alright. So now, how does this apply to any sort of idea of chemical bonding? Well, chemical bonding happens when two elements interact in a way where they either transfer or share electrons, share valence electrons, in fact, electrons that were on the outermost energy level from the nucleus, in order to create a situation in which both of their valence energy levels have the complete number of electrons. So therefore, and this represents an idea of when the valence energy level is full, valence energy equals full, this creates what we like to call in chemistry energetic stability. And so this almost explains exactly why. Why would atoms bond? Well, they have an affinity. They wish to become more energetically stable, more, from a physics standpoint, electrically stable. This attraction between the protons in the nucleus and electrons in the energy levels. They want to, the atoms want to create a state of lowest energy as possible. And so this is why they bond, to form what they call, when they bond, A species that bonds is called a compound. A compound. And a compound is made up of a combination of elements, which are the fundamental units of any sort of species of hydrogen or helium or any other matter. All right, now let's do an example. Let's go back to the one that we had in the last video. We drew out the structure of lithium and fluorine. So let's do that again. Let's go lithium. And lithium, we know lithium has 3 protons, 3 neutrons, but most importantly, what we'll be focusing on most in this video is 3 electrons. 3 electrons. So we're going to draw the nucleus. Very squeaky pen. Marker, my bad, marker. And there are the 3 positive charges followed by 3 neutrons. Now, we know in the first energy level there are 2 electrons that will fill this energy level. There they are, and we, again, as I mentioned in the last video, we are for now going to assume that the energy levels are circular and that they surround the nucleus in a manner that allows the electrons to almost, in an idea, orbit the nucleus. And this is what we're going to stick with for now until later videos. So now the 3rd electron will go in the 2nd energy level, because as we know, lithium is part of the 2nd period and it's when it's organized in the periodic table, so it will have 2 energy levels that contain electrons. So 2 energy levels. So now let's draw out fluorine, and then we're going to get to the meat and potatoes of this entire idea of chemical bonding. So now we know that there are 9 protons and 10 neutrons, and then finally 9 electrons. So this is the number, again, that really matters, because when we are talking about chemical bonding, we are talking about a transfer or at least a sharing of electrons between two atoms or elements. So this is the nucleus. We have our protons equal 9, our neutrons equal 10. And so now we're going to draw our first energy level. Again, our first energy level is going to have 2. It's going to have 2 electrons. And then our second energy level, because we know that fluorine is a group 7, it is a group 7 element, it is going to have 7 valence electrons. 7 valence electrons. And so this is the atomic structure of fluorine as we saw it in the last video. Now, as I discussed earlier in this video, the rule that when the valence energy level is full, energetic stability is achieved by the element. So, as we've talked about in previous videos, elements have the ability to lose an electron. They have the ability to give away an electron or to accept an electron in order to create this idea of energetic stability. And this is exactly what a chemical bond is. Here, in this situation, the lithium is able to transfer this electron directly to the fluorine. And this creates a situation where the valence energy level now becomes the first energy level for lithium, because it just lost the only electron it had in the second energy level. And this first energy level is full. It's a full energy level for lithium, so it has achieved energetic stability. Let's cross that, star it a little bit more, because it's super important for chemical bonding. And now for fluorine has also gained. Fluorine has gained a full outer energy level in its second energy level. It has gained another electron. It now has 8 electrons in its second energy level. And this completes that energy level. And so therefore both of them have achieved this energetic stability that we are talking about. But now how does this apply to this idea of bonding? Sure, they've transferred the electrons, but why is it exactly, what is this idea of a compound? What does this mean for something to be in a compound, to be in a combination, of elements? Well, when lithium and fluorine bond, when this idea of bonding, this idea of transferring the electron, they become a single thing called a compound. And this compound is called lithium. You write L-I-F, and it is called lithium. Hold on. No, I ran out of room. I have to fix this. We cannot have this atrocity on this channel. Okay, lithium. Rewrite that. It is called lithium fluoride. And the reason for the change in the name of the fluorine, it would normally be fluorine and lithium are the two elements, but the name of the compound is lithium fluoride because the I represents the ionization of fluorine. Because if we erase, oh, I don't want to erase this, but I might have to. Yes, we are going to erase this top part. If you look at the way this compound is set up, it is actually an attraction between oppositely charged, what we call ions, which are charged atoms. And we know, obviously, even just from a common sense point of view, that any oppositely charged species will attract each other. So we know that lithium, when it gives away its electron, it becomes lithium plus. Because when it gives away a negative, it takes on the positive because it no longer has that negative to balance out. It has more protons, more positive charges than negative charges when it loses its electron. So, when it transfers it to the fluorine takes on a negative charge because now it has more electrons. It has more electrons than protons. So therefore, a net charge of negative 1. And so this matters because now that we've established the charges on these species, once the electron transfer has occurred, they can be considered bonded. And there's a much longer process called the Born-Haber process that we will talk about in much later videos. But this is the basis of the chemical bonding, and this is the basis of what we as chemists call ionic bonding. And the reason for this is because it is the combination of ions. It is the combination of the ions once the electron transfer has occurred. But is there any other way of forming a chemical bond besides simply transferring an electron? Well, it turns out there actually is. And this occurs between a nonmetal and a metal. See here how lithium bonded with fluorine. Lithium is a metal, fluorine is a nonmetal. And so this idea of ionic bonding in general is made up when a metal reacts. And this idea of reacts, when electrons are transferred, that's when you have this idea of reacting is present. Metals react with nonmetals, which is exactly what fluorine is. Fluorine is a nonmetal. It is on the right side of the periodic table. So now we are going to erase this bottom example, and I am going to show you an example of a non-ionic bond, of what we call a covalent bond. In this covalent bond, this idea, it does not involve the transfer of electrons. It involves the sharing of electrons. Covalent bonds, so nonmetals that form covalent bonds together, they are not greedy. They are the peacekeepers in society. They donate to charity. They help everyone out. They do not take for themselves. So we are going to erase. And so let's say, for example, that we have the compound of nitrogen. We have the compound of nitrogen oxide. Nitrogen oxide. So we are going to draw. Now let's just ignore for a second the innermost energy levels and just focus on the second energy level, the one that will bond in this instance. So we know that nitrogen has five electrons in its outermost energy level. So that means that it will have one pair and then 3 sitting on its own. And we will talk about exactly why that is in the bonding video. In the orbital video. And so we have the nitrogen right here. And now, actually let's not talk about the nitrogen oxide. Let's talk about just the nitrogen molecule. And this nitrogen molecule actually has the form of N2. Whenever nitrogen appears in nature, it will always appear as not a single atom. It will appear as 2 atoms bonded together. And so this nitrogen here, we're going to do the same thing. It's going to create the exact same sequence of electrons, like this, in this sequence. And now, this idea of covalent bonding. These nitrogens want to see their outer energy level satisfied. They want to have it full of electrons, which means that they want it to have 8 electrons. So how does this happen? Well, this electron comes here, but it brings the nitrogen atom with it, meaning that these pairs of electrons are part of both atoms. They are a bonded part of both atoms, meaning that these 3 pairs of electrons that are created, they belong to both atoms, which means that now both atoms have 3 pairs that were created, as well as an additional pair that was present due to the idea that there are 5 electrons in the valence energy level. And so this is the major difference between ionic bonding and what we call covalent bonding. Covalent bonding is the sharing of electrons. It is the sharing. Covalent bonding is the sharing of electrons. No ions are created. There's no loss of an electron by either nitrogen. It is simply the sharing of electrons. They are helping each other out, as I would like to say. So what is the difference? Why is it that some of these elements, such as nitrogen, when they bond together, they do this sharing thing, they do covalent bonding. Whereas when a metal and a non-metal combine, they do what we call ionic bonding, and they transfer an electron. They initiate this idea of ions reacting together. And the big concept behind this is called, ready for this? This is a huge word, and it is very important. It is one of the most important bonding words, electronegativity. Electronegativity. And the rigorous definition, which we will talk about in the next video when we talk about atomic properties, is the tendency of an atom to attract bonding pairs of electrons, which means that it is the idea that here, if both nitrogens want the electrons the same amount, neither will pull the electrons away from the other. Whereas if fluorine wants the electrons way more than lithium, which is the case in this electronegativity concept, which is measurable by this thing called the Pauli system, by the Pauli measurement system. This fluorine wants the electrons way more, so it will take away the electron from the lithium atom, and it will leave the lithium atom as an ion, a positive ion, and that is how these guys will bond. And just one last note before we leave this video. Because these ions are created, this bond happens to be much, much stronger than this bond, because they are ions attracting each other rather than simply a sharing of charge between two atoms. So this is the idea I'd like to leave you with. Do not forget this word. We will talk about it in the next video. All right, have a good night, everyone.